All right. So thank you very much for having me in this webinar to present my topic. My name is Hala. I am a PhD candidate at Latrobe University conducting a research on strengthening timber structural elements. So the topic of my presentation today is a refined finite element model for predicting strength and serviceability behavior for timber composite beam, which is TCB. So the agenda of my presentation will start with introduction to my presentation to the topic, and then study aim, methodology, conclusion, and references. So I'll give you a bit of introduction about sustainable buildings and timber buildings. So as we all know that sustainability has recently become the priority focus in many businesses and industries, especially in the building and construction industry. So the current sustainability design frameworks and the innovation of engineered wood products, asset engineers and architects and planners to move into a new direction and creating biophilic, eco-friendly buildings and cities using sustainable materials like timber. So as we all know, timber is a sustainable material as it proves the principle of sustainability. It is environmentally friendly. It has positive impact on social and community, and also it is cost effective. So in terms of environmentally friendly, it has a low impact on the environment. It is renewable resource. It has less greenhouse gas emission. It can observe the CO2 from the atmosphere. In terms of having positive impact on social and community, so it provides healthy environment, and for labor and workers, dealing with timber is very easy. It is easy to handle, easily transported, easy to build and construct, and also it requires less heavy machines in the site. In terms of the cost effective, mostly it is locally available and fast delivery, required less people or less workforce on the site. So all these elements make dealing with timber or using timber in the building cost effective. So in order to extend the use of timber structural member and produce a long structural beams with high strength and good serviceability, and reduce the use of traditional building materials like steel and concrete, it's found that it is important to strengthen and enhance the strength properties and the serviceability of behavior of timber structural elements. So therefore, after investigation, it's found that there are two methods in general to strengthen the timber beams or the timber structural elements. The first method is internal strengthening method, and the other method is external strengthening method. The general strengthening materials used, whether for the internal or the external, are either metallic materials or hardwood compress dowel or fiber reinforcement polymer composite materials. So those are in general the timber strengthening materials. Now, in order to find what is the best type of timber that is locally available and work on improving its mechanical properties or its strength properties, I have reviewed a number of tests in order to decide on what type of engineered wood product that I will work on in order to improve its strength properties. So I have reviewed 10 strengthening methods in order to see the improvement percentage and decide the type of timber. So as you can see in the figure, 5 external strengthening methods and 5 tests used internal strengthening method. And after measuring the improvement percentage of each test, it's found that the best test to or the best type of timber that is good to work on is the glulam. However, glulam is not locally available in Australia, and my aim is to produce a sustainable building. So I'm trying to find and work on a type of engineered wood product that is locally available. So after deep investigation and contacting many companies, it's found that LVL also it's locally available, and it is good. It's mostly used in many building, and according to the reviewed strengthening test, it's found that the improvement percentage using carbon fiber reinforcement polymer sheet to this type of timber improves the properties or the strength properties by 30%. So in my research, I have decided to work on this type of timber, the LVL timber structural member. Now, so the study, the aim of my study is to find an optimum economic solution to strengthen timber structural members via conducting a computational study and developing a model that is capable of predicting the strength and serviceability behavior for timber composite beam. And also by conducting this computational study, we can reduce conducting physical experiment to just find the mechanical properties of particular structural member or structural problem. So by developing a computational model, this will help a lot to predict the properties, to predict the strength properties and the serviceability behavior for any structural member. So the methodology that I used in my study is divided into 4 stages, as you can see in this figure. Stage 1 is reviewing the finite element software. And then stage 2 is developing a finite element model. And then stage 3 is just analysis and result for the model. And then stage 4 is about result validation that's generated from the model. So starting with the stage number 1, the type of finite element modeling software that I have reviewed is ANSYS and Abacus. And after a deep investigation on which one I will select, I have decided to choose Abacus due to many reasons. And then after decide the type of the software for the modeling, I moved to stage number 2, which is developing the model. In developing the model, I have developed the 3D finite element model using, as I said, Abacus software, and the version was using the standard one, 2021. Now, in order to develop this this model and estimate or measure the strength properties of the structural member, there were steps to develop this model. Those steps were divided into 2 phases, 2 main phases. The first one is the preparation phase. Here where we need to define the structural member or the structural problem. Then in the second phase is also divided into 3 steps. Firstly, pre-simulation process, and then simulation process, and then post-simulation process. For the pre-simulation process, here where we need to create an input file, like the geometrical characteristic of the structural member, the properties, the mechanical properties. This include the elastic properties of the member, and then assemble the member, and then move to another step, which is the simulation process here, where Abacus will analyze the model. And then after this step, it will be a post-simulation process where we need to extract the result and do evaluation. So example of the first step, as you can see here in this figure. So the preparation include like decide the type of the test. And in my model, I've decided to do a three-point flexural test. And specimen index is engineered wood products. So EWP stand for engineer's wood product. And detail that the name of the specimen is TCP, timber composite beam, and the geometrical characteristic of this member length is 2,400 by 240, and the depth is 45. Span length is 2,100. This is the preparation after decide on the geometrical properties and the type of the test. Now moving to the software, to phase number 2, where we need to develop the model. And as you can see here in this image, so phase 2 will be focus on all the model tree here on the left side, starting with the part material assemble here, where we need to input the information that are required for the model. In the part here, where we need to input the details of the structural member in terms of the length, width, and the depth, and draw or sketch the shape. And for the material here, where we need to input the material properties and assemble, because we have two parts here, two shapes, one for the timber and the other one for the strengthening materials. And then also decide on the constraints and the boundary conditions, like we have here two simply supports and also the load. So all this information will be in the first step, the pre-simulation process. Then for the step and field output request and history, this is going to be for the second one, the simulation process, and then submit the work in the job for the analysis and later on the evaluation. After completing the model and submit it for the analysis, then the result, I've downloaded the load displacement curve for the model, and from the load displacement curve, we can estimate the fracture load, the ultimate load carrying capacity, displacement, and other strength properties like ultimate bending moment capacity and stiffness of the member. So here is example of the extracted result. We have fracture load, ultimate load carrying capacity, and displacement. Now, after completing stage 3, the result, we need to evaluate or validate the predicted result from the model, moving to the next stage, which is stage number 4. In stage number 4, result validation, the result of the predicted final element model has been compared with the result obtained from experiment found in the literature. And as you can see here, the fracture load is for the experiment is also 42.5, so the error percentage was 0. Ultimate load carrying capacity was 30%, and also for the predicted model was 30, and displacement found 16. So the error percentage was 0. And this is indicated that the predicted results were in high agreement with the result obtained from the experiment result found in the literature. As a conclusion, the proposed finite element model presented in this work shows high efficiency and capability in predicting the strength and serviceability behavior for timber composite beam, and the predicted results were in high agreement with the experimental result data adopted from the literature. And those are the references used in this presentation, and thank you.
Thank you so much, Hala. Any questions?
Yeah, I have a few questions, if that's okay.
Yes, go ahead.
So one of the questions was, how do we go about implementing more of these structural beams or more of these structural timbers in construction sites?
Sorry, can you just say it again?
How do we go about using more of these structural timber components in our construction sites? So if we have, for example, there's already LVL beam glulam available, how do we go about implementing them in, you know, for example, more houses or more buildings, etc.?
You can decide in the design stage the type of the timber that you will use in the in your project. So if you decided to use the LVL, then this should be identified in the design phase of the building.
And how is the what was it? The fire requirements of these structural beams? Are they, you know, very safe to use in, you know, commercial environment, etc.? Or
yes, this is a good question. Well, it's for the engineered wood product, they are treated, and the fire safety measures have been evaluated for it. For extra information, I just would like to keep it for now for publication purpose.
Yeah, no worries. Thank you.
No worries.
Right. I had a couple of questions as well, if you don't mind.
Yeah.
One of the troubles that I have with timber is being actually environmental, because there's an argument that we're cutting trees to build houses, and that is basically a non-environmental friendly act. Plus, it can be affected by termite, and that is why the steel lighter steel frames are taking place instead of timber. So I don't know if you can convince that this is actually an environmental friendly approach for construction.
Also, we are working on it for the harvesting and cutting the trees. Currently, according to the research, shows that the industry are following a sustainable plan for harvesting and cutting trees. So there is already a plan for this. However, because I'm working on this and this is part of my research, so I just would like to keep the further clarification.
That's all right.
For the publication.
Thank you so much. And so overall, another question I had was that there were two methods in your research, and one of them was internal strengthening and the other one was external strengthening. And the one that was exactly so we've got better results from internal strengthening.
Yes.
Okay.
Yes, because this is for test number 9, engineered timber product, which is glulam, and the type of the reinforcement method is using fiber reinforcement polymer pins.
So how does that work actually? There are some pins out of a fiber material.
Yes.
And they are being nailed inside the
the beam. Yes, to improve its strength properties. Yeah.
So it's not like something a jacketing a timber beam? That would be external.
No, this is different. This is internal pins, long pins, according to the depth of the beam. So inserted inside the structural member to improve its strength properties. Yeah. It is, glulam is one of the good structural members. However, it's not locally available in Australia, and it's also expensive. And in my research, I'm focusing on producing a sustainable solution to improve the behavior of the timber structural elements. So that's why I have reviewed a number of engineered wood products, and one of these is also LVL. LVL is locally available, and the price for LVL is acceptable. However, there are some limitation of using the LVL as the main structural member in some mid or high-rise building. So I've decided to investigate further on this type of structural member and find an economic solution to improve the strength and serviceability behavior for LVL.
Thank you so much, Hala.
My pleasure.
So yeah, it was all of the presentations today. Unfortunately, we couldn't catch up with Isaac for many reasons. As we have now concluded the final presentation from the 5th International Webinar on Construction Materials, I, on behalf of the organizing team, want to thank everyone who had joined this webinar. It was such an absolute privilege to have some of the brightest minds in the construction industry presenting their latest achievements. We hope that you take away a handful of resources for your next move in construction. The certificates of presentation and attendance will be sent within the next few days. If you have not registered through our website, please make sure to send us your email should you wish to receive your certificate of attendance. Once again, thank you and hope to see you next year.
Thank you. Thank you, Farad.
Thank you.
Nice to meet you, Anshush.
No.